Hello and welcome. My name is Brian Shumate. I'm a product education engineer at HashiCorp. I am here today with my colleague Jonathan, and we're going to discuss Vault operations with Terraform and HCP. We're going to introduce some concepts about codifying Vault and how you can manage the lifecycle of Vault from an OSS standalone Vault self-hosted to migration to HCP Vault, and then we're going to discuss management and scaling HCP Vault. So first, a little housekeeping. I want to mention we have a code of conduct here. The HashiConf organizers do our utmost to ensure all conference attendees feel safe, whether you're attending virtually or in person. We want to make this a harassment-free conference experience, regardless of gender, sexual orientation, disability, physical appearance, body size, race, or religion. If you need to discuss this, you can learn more about the code of conduct at this link, and you can also talk to one of our teaching assistants who I'm introducing here. I'd like to give a shout out to our teaching assistants for this presentation, Sebastian, Tom, and Kojak. You can ask any of these folks questions directly in the Zoom chat during this presentation at any time, and they'll help you out. Okay, so moving right along. This is going to be a two-part presentation. My part is going to be about running a self-hosted Vault with codified configuration and then sort of migrating that configuration and applying it to an HCP Vault cluster with Terraform. And then I'll hand off to Jonathan for his section. So migrating to HCP Vault is a pretty hot topic right now. As part of any cloud adoption strategy, you might be tasked with migrating a self-hosted Vault to HCP Vault. To that end, we have some excellent documentation that I'd like to call out on the left here, migration strategies and considerations that you should review thoroughly as any part of any migration strategy to HCP Vault. You definitely want to give that a good deep read there. And the strategy that I'm covering today involving Terraform codification is discussed in this documentation as well. We also have an excellent video explainer as part of a HashiCorp brown bag for Vault that you can check out on YouTube there. You don't need to necessarily note these links right now. We will be sharing all the presentation material and links at the end as well. So my part, all of this is brought to you by codification, which is a concept whereby you store your configuration for Vault as code. In this case, we're using Terraform with the Vault provider. This gives you a lot of benefits. Number one being increased productivity with respect to deploying Vault. You can deploy Vault very quickly with Terraform and get up and running a lot faster than just typing commands in at a terminal. It's very reproducible. You can get an environment much like a previous one deployed in a different platform, for example. It's less error prone, less human error and bugs when you codify, and the process is extremely well documented as well. So you'll see here we have 3 tutorials on the Learn site which discuss codification of Vault, and they cover most of the areas. So for example, on the left, we have codification of Vault open source, codification of Vault Enterprise, and codification of HCP Vault. So we have 3 existing tutorials if you're unfamiliar with the actual concept of storing your Vault configuration as code that you can refer to, which will help you get up to speed. All right, before we begin with the actual hands-on lab portion of my presentation, I wanted to cover some points that you should be aware of regarding this workflow that I'm going to demonstrate for you. Number one, it's not for all use cases. The particular use case that I'm sort of demonstrating here would represent quality assurance or user acceptance testing Vault cluster that you start with in a self-hosted capacity and then need to scale up. And so therefore you would move to HCP Vault, and you can take your use cases to HCP Vault through this process, but other use cases, this workflow may not be the best for them. Another thing is that in HCP Vault, you need to enable the public interface, which is something that's typically not encouraged in production. And I'm going to be demonstrating that here for simplicity, but in a production use case, you would want to use internal resources, keep things internal, and maybe use a bastion host in a VPC that you have peered through a HashiCorp virtual network to your HCP Vault. One thing you need to be aware of, if you have existing audit devices in your vault, those cannot be migrated with this workflow. HCP Vault has its own file audit device, and it doesn't allow granular configuration of the audit devices. So that's something to keep in mind if you're using, for example, a socket-based audit device or something in your vault. You'll have to disable that before you try to migrate. So your storage backend can also change because HCP Vault uses integrated storage, or also known as RAV storage. So if your local or self-hosted vault is using Consul or the file system backend or something similar, you should be aware that when you do the application of your configuration to an HCP Vault, it's going to have a different storage backend potentially, unless you were previously using integrated storage. These are two distinct clusters. The seal is actually not migrated, so you won't be able to use your previous unseal or recovery keys. They're literally two distinct clusters that you're just taking configuration from one and applying to the other. And then finally, HCP Vault uses the Enterprise edition of Vault with namespaces feature, and it has a particular default namespace named admin. So you will need to keep this in mind when working with HCP Vault and the provider as well. So moving along, this is exactly what we're going to go through here. I'm going to start a local dev server, dev mode vault, and I'm going to show the Terraform configuration that we'll be codifying the Vault server with. We're going to apply the configuration to the server. Then we're going to manually validate it by retrieving some secrets and authenticating with Vault rather. So after we've done that, we're going to update our local environment a little bit. We're going to get some information from HCP Vault. We're going to then apply our configuration to the HCP Vault and do a similar validation of the configuration in HCP Vault. And with that, it's pretty much time for the hands-on lab portion. So let me move over to this environment. This is our hands-on lab. Actually, I'm sorry, let me show you the tutorial. We have a published tutorial live that lets you walk through all of the material that I'm covering here in your own environment, or you can actually use an interactive lab that's built in, and this is how I'm going to demonstrate it to you here. So this tutorial will be linked at the end as well with the rest of the resources so that you can check that out also. So I'm here in the local environment. We have two environments here, the local where we'll self-host a vault, and then our HCP account, which I can also pop over here and show you briefly. So in our local account, we're going to go ahead and get started here by starting a Vault dev mode server. We're going to use no hup in case we lose the controlling terminal so the Vault doesn't stop. We're going to export a Vault adder to address this local server. And then we're going to use the initial root token value of root. Since this is just a dev mode server, that should be fine. We'll check the Vault status. Okay, something I want to point out here, if we note this Vault status, we're running version 1.10.3. We're using nmem storage. These details are going to change when we deploy to the HCP Vault. So I'm just pointing them out here now so that you can notice that. Finally, I'm going to make sure my root token is actually working and I can do a token lookup against Vault. So Vault is ready to go here locally. Let's go ahead and proceed to the next challenge that's part of this lab. Okay, in this part, we're going to examine the Terraform configuration. So we have all of that in a directory here, and we'll change into that directory. Take a quick peek at the files within. It's Terraform configuration and Vault ACL policies. We can open these in a text editor here. And we'll just hide this for now and go through all of this content. So starting with our ACL policies, we have an admin policy, and this gives broad admin privileges over auth methods, tokens, ACL policies themselves, secrets engines. So this is kind of like a pseudo policy somewhat for an admin persona. We have a student persona who has a much more restricted policy. This policy limits them to a secrets engine at the API credentials path up to student here. They're allowed to do CRUD operations. They also have access to a transit secrets engine key as well. So it's a very limited scope set of policies compared to the admin policy. Our Terraform configuration, I'll start with the main configuration. It's actually more comments than code here. We have some helpful tips in here. One thing you can do to protect your state with Terraform, you can encrypt the back end. If you're not using Terraform Cloud, you can also use Terraform Cloud, of course. That's definitely recommended. But if you're using Terraform in a standalone way, you can use an encrypted S3 bucket, for example, and that'll keep your state protected while you're using Terraform with Vault and the Vault provider. So that's kind of called out here in comments, but we're really just going to use local state for this demo. The Vault provider here is also empty because we recommend that you use environment variables such as Vault adder, Vault token, and so forth to configure the Vault provider rather than hard coding it in the configuration here. So going back up to our ACL policies, these are the two policy resources which literally read in these ACL policy files and create the actual policies named admins and student secrets. We also have auth methods here where we enable a username and password auth method, and we actually create two users, the admin user and the student user. And a few more points, secrets engines here. We're creating a KVV2 secrets engine at the path KVV2. We're also doing transit, and I'm sorry, the API credentials is the path, and that's kind of critical there. We're creating a transit secrets engine here and the key that I mentioned before. And then finally, we're actually creating some static secrets themselves that we can retrieve later in our testing. So I'm going to switch back over to the CLI portion and bring out our instructions here. And so we've reviewed all of these policies and configuration, and we're now ready to proceed to the next step. Okay, so in this challenge, we're actually going to go back into our directory with the Terraform configuration, and we're going to run Terraform init to prepare our workspace here. So that's done, and then we will apply. So when we run Terraform apply, we get all of the plan here, as you would expect. If you're familiar with Terraform, all the resources it's going to create are spelled out here, and you can review this plan. And then if it looks good, go ahead and answer yes, and it will be applied. And as you can see, we've created our resources. So Vault now has this configuration available. We can move on to testing. So what we'll do, instead of using the root token here, we're going to unset the Vault token environment variable, and we'll actually log in using the username and password auth method as the student user. So that password is right here. We'll provide that, and you can see we're now logged in. So this is still the local self-hosted Vault. We're logged in using the username and password auth method as the student user, and you can see we received a token that has the default and student secrets policies. So we can, now that we're authenticated with Vault, we can list the API credentials path, that secrets engine, and we'll notice we have some keys in there, admin and student. We can go further, try to be a little sneaky and list the admin keys and see that there is an API wizard value here. Why don't we see if we can get that? Absolutely not. The policies are working as intended. The student user is not able to access that path, so we get an error instead. So why don't we look at something we actually do have access to, the student path here. We have an API key and something called golden in there. Let's try to get the API key. And that does succeed. So our policies are working. We have authenticated, retrieved the secret. Everything's working here in our local self-hosted vault that has been codified with the Terraform vault provider. So now our next step will be to prepare our environment so that we can apply the same configuration to an HCP Vault cluster. So back into that same directory again, and what we'll go through these changes here. One of the most important considerations, as I mentioned previously, is that HCP Vault uses an enterprise namespaces feature, and it uses a namespace named admin. So we need to account for that, and what we can do is set a Vault namespace environment variable with the value of admin. So we'll go ahead and do that now. And that takes care of addressing the proper namespace in HCP Vault. And so now we need to go and get our public address for our Vault cluster. So the way we would do that is hop over here into HCP. In the Vault overview, we scroll down. There is a public cluster URL here, and we can copy that to our clipboard, go back to our environment, and what we want to do there is set this value to the Vault adder environment variable. So I'll go ahead and export that now. Okay, and then likewise, we need a token for the cluster, an admin token, sort of like our initial root token for the local one. We can get that here by generating one. We'll say generate admin token. And there we have our token value. We can copy that to the clipboard, return back to our environment, and we want to export this as Vault's token, as you see here. So we'll go ahead and do that. Okay, I'm going to clear this, and then we are done with the changes. It's really that simple, just a few environment variables, and we can literally apply this configuration now to our HCP cluster with Terraform apply. So we could review the plan again. I'm going to go ahead and say yes, apply that. And the application was successful here too. So now our same configuration that we previously had in our local self-hosted vault has now been applied to the HCP Vault cluster, and we can go ahead and validate this. We can look at our Vault status first, and we'll notice it's completely different from the local self-hosted. We're now running the enterprise version of Vault, as expected on HCP. We're using wrapped storage, the integrated storage, and all of our cluster ID and so forth values have changed here. So we are on HCP Vault now. Hooray. In addition to that, we can go ahead and do a similar confirmation by authenticating. So we can unset that root token. We can log in with the username and password auth method. This time we'll use the admin username instead of student, just to mix it up a bit. And that has a different password here. So we'll provide that. So now we're authenticated to the HCP Vault cluster as this admin persona, and our token has an admin policy or admin's policy on there. Let's see, if you recall, the student persona had some interesting keys in there. They had one called Golden, I think, in their API credentials. You can take a look at that. It's kind of odd looking. It has a key called egg B64, which is interesting. I guess that would imply it's base 64 encoded. So we could probably use a command to get the same secret again, just get that field egg B64 in and pass that to base 64 decode operation. And we get a surprise. Okay, so this is literally all of my presentation at this point. So I'm going to go ahead and hop back over to my slides and say thank you. and hand it over to Jonathan.
Awesome. Thank you very much, Brian. So at this point, we've got an environment that's been migrated from self-hosted Vault to HCP, whether that's self-hosted in your own data center, self-hosted in AWS. You've now been able to take that configuration and migrate to the HashiCorp Cloud Platform. But as we all know, migrating to the cloud is only one step in the process. There are still other things you need to do to maintain your environment. So in this part of the lab, we're going to talk about how you can manage your HCP environment. You might have to do things like scale up your cluster. Right now, Brian's migrated his self-hosted Vault to a dev tier cluster. That might be great for proof of concepts or additional testing, but probably wouldn't work for production workloads. You may also have the need to add performance replication. Maybe you've got applications that run in different environments or different regions. So rather than having those Vault requests go across a country, you can set up performance replication and replicate all of the configuration from your primary cluster to your secondary. And most workloads are, have some peaks and valleys. They're not consistently requiring a lot of resources. So how can you manage cost while you're running an HCP? Maybe you've got some spikes in workloads that happen in other regions at certain time of the day, but then at other times you don't need to run additional workloads in other regions. So how can you scale your HCP environment back down to a single region and help you manage cost? So right now you're here, you've got a dev tier HCP Vault environment, and you've got the configuration that has been pushed up from Terraform. But this is where you want to get to. You want to have a larger Vault cluster for production. You want to add that performance secondary for your applications in other regions, and then you want to scale back down. If you think about how that might have worked with self-hosted Vault, there's a lot of different people that may need to get involved in order to scale up a Vault cluster, a self-hosted Vault cluster. There are different people that would need to be involved in replication and security, who's going to access that. So you think about your self-hosted clusters, you may have some group of developers working on applications that need to consume secrets. In a production environment, maybe they're managing path filters. Your SecOps team also might be managing that. When you think about replication, especially over long distances, you've probably got to involve a network operations team to consider latency so that your replication is working as expected. If something's written to your primary, it's then available also in your secondary. And then who's managing access to Vault, who's managing replications and replication settings and auth methods and things like that. So you've probably got another security operations team that's going to manage all of that in a self-hosted environment. So a lot more people needed to, do those three things: to scale up your cluster, to add replication, and then sort of manage it as your consumption changes. With HCP, you can scale all that down in terms of who has to manage your HCP environment to, let's call it an HCP portal ops team. This team has access to your HCP portal environment. They're able to create HVNs, which is the first step in deploying a new HCP Vault cluster or adding a performance secondary. They can enable replication. They can even manage path filters directly through the HCP portal. They don't have to necessarily go into the Vault UI to change any path filter settings. So simplifies your management of your Vault environment being on HCP. So if you take a look at some of the code, the Terraform configuration Brian shared, and look at the resources, the ability to scale up is really managed by one setting in your Terraform configuration. So if you look at your HCP Vault cluster resource, there is a tier setting, and you can manage the tier simply by making a change to that setting, which we're going to take a look at those configuration files now. So similar to Brian, I've got a list of all my config files here. The ones we're going to look at are main, outputs, and variables. My main configuration just has my provider in it with any provider configuration options that you might need. In this sample one, it's pretty basic. The variables have a list of all of the bits for my HCP Vault configuration. So I'm defining the cloud provider, which at this point is AWS. I've got the tier defined here. So when I deployed this, it was a dev tier cluster. So again, small, not necessarily production ready. I can pick which region I'm going to create my HVN in. This is going to impact where the Vault cluster is deployed. So if I attach it to this HVN, my Vault cluster is also going to appear in this region. Some IDs and the CIDR range for my HVN. When you are doing replication, just be aware that these CIDR ranges can't overlap. So when you create your secondary cluster, and you'll see this in a little bit, you want to make sure that your range does not overlap there to cause any potential routing or access problems. So that's my variables file. The HCP Vault configuration, there's really two resources that you need here. I've got a couple extra ones in there just for demonstration purposes, but the HVN, this will create the HVN in your HCP account, and the Vault cluster resource, this will create the cluster once the HVN is created. I've also got an admin token in here so that I can access the cluster when it's first spun up. You would need that for some initial configuration. Once you've, if you want to push like a self-hosted Vault config like Brian did earlier, you'll need that initial admin token to be able to access the environment. And then I have some outputs here that I can use to interact with my HCP Vault cluster once it has been deployed. So I'm going to do a Terraform apply now. You can see it's going to create several resources. It's going to have those outputs that I just showed you. And I'm going to change the tier from dev to plus. Plus tier is where I can do replication. I could go from dev to starter, starter to standard, standard to plus. I can bounce between all of those tiers. The only caveat is once you've left the dev tier, you can't go back. So once you go from dev to plus in this example, I can't scale back down to dev, but you could scale back down to starter, which we'll do later on in this lab. Just want to make sure that my tier has changed. So looking at the variables file again, I can see that the tier is now set to plus small. One cool thing when you're doing this also on HCP is that the Vault cluster is live the entire time you're scaling up or down your cluster. So you'll notice, nope, sorry, I scrolled by that. Yeah, this is going to happen in place. So while the cluster is being upgraded, all of your applications will have access to that Vault cluster. So if they need to read secrets or authenticate with some auth method, this cluster is going to be available the entire time it's being upgraded from dev to plus. So I'm going to kick that off. And let's go. And yeah, so here's my HCP portal. You can see that my cluster is in the process of updating. And while that's happening, I can still access the, in this case, the UI. I can log in with username and password and go look at those keys that Brian had created earlier. So if this is an app that needs to retrieve these keys, those are all available while this upgrade is happening. And we should get to a point where, yep, we are upgraded. So now the dev tier cluster is at the plus tier. So basically what we've done now is that first step, you've scaled up from dev to plus. So that is done. And now we need to add replication. We may have some, I mentioned like an application that runs in a different region. Maybe that's at different times of the day, different times of the month. So you can add replication pretty easily because you've done everything so far through Terraform by adding additional resource blocks to your config. And it's essentially the same. You're going to have HVN. You're going to have another cluster block. The only difference for your secondary cluster is this setting here, the primary link setting. You are going to define that, and that's going to tell the HCP provider that, hey, this is a secondary cluster. So this isn't just some new standalone individual cluster. We want to link this to our primary cluster, and that's going to enable replication. So really with one setting in Terraform, you can build out a performance replica in HCP Vault. So let's go take a look at what that might look like. So this is where we left off. We had just upgraded from Dev to the Plus tier. And now I need to add some additional information into my configuration. So these are the settings for my secondary cluster. So I've defined a different region, different HVN ID, different CIDR address, which I mentioned earlier. This needs to not overlap with your primary, and a name for my new Vault cluster. And that's going to get jammed into the variables configuration. So you can see here, all of those variables are in that one file now. And then I'm going to add the additional resource blocks to my HCP Vault configuration. Again, pretty much the exact same setup, just with different values and that primary link setting, so that when this is deployed, HCP knows that this is a replica and not just a standalone separate cluster. And I'm going to add an output for my secondary cluster URL so I can interact with that once it's been deployed. And going to deploy that. While it's deploying, you can see the, if you log into the HCP portal, you can see the secondary cluster being created. This little arrow here designates that it is a secondary of the cluster above. So if you're looking in the UI, that's one way to visually see that you've got a secondary cluster. The other is looking at the replication field, whether it's the primary or the secondary. And when we wrap up here, it'll give me the new output for my secondary cluster URL that was added. And I'm going to unset my root token or my admin token from the initial setup. And I'm going to log in now using the secondary cluster output and the username and password that was part of the environment that Brian had migrated from our self-hosted vault. And I should be able to authenticate with that, get back my token, since I logged in as admin, get the appropriate policies back. And I can look at the vault status. I know that I'm on my secondary cluster because I can see my address falls within that secondary CIDR range that I defined in Terraform. And I can see that it's running, and there's my there's the secondary range, just so you can see it visually. And finally, it's just I'm just going to list out the secrets engines that are available, so you can see everything that was pushed up from your self-hosted environment to HCP has now been replicated over to the secondary. So really, with just a few lines of Terraform, you've gotten steps 1 and 2 done. You have migrated from the dev tier, and you've added performance secondary in another HCP region. For anyone that's been in the industry long enough, you know that once you do something, inevitably somebody reminds you of something that you should have also done, but you didn't get all those requirements necessarily. So in this scenario, we just let everything replicate from the primary, but maybe there's some secrets engine or auth method that we don't want to have replicated over to our secondary cluster. And you can manage that with path filters. One of the things I love about doing this in HCP is I can do it all through the HCP portal. So I'm back here in my environment, and I want to maybe remove the transit secret engine. So I can do that by adding an additional line to my secondary configuration, this path filter line, and I can provide it some list of paths that I don't want to have replicated over to my secondary. So in this case, going to take the transit secret engine and not have that replicate over to the secondary. It's there now, but once I apply this, it will get removed. So I'm going to add this and then take a look at the configuration again. You can see the path filter setting here with the transit path is what I'm going to add. Path filters in HCP are always deny path filters. So if you add something here, it won't be replicated. And let's apply the configuration. That's done. And now if I go back and look at the list of secret engines, you'll see that the transit secret engine has been removed from the secondary cluster since I've added that path filter setting to my configuration. All right, so far with maybe 20 lines of Terraform or so, you've scaled up your cluster, you've added replication, and you've added path filters. So in HCP using Terraform, this is a very easy thing to manage. But now we get to a point where we don't necessarily need the secondary cluster anymore. So how do we change that? It's actually pretty much the same way as scaling up our cluster. We want to scale that back down. There's a number of different ways you could remove the secondary. In the demo here, I'm just going to remove the resource blocks from my Terraform config. And then I'm going to change my cluster tier here back down to starter so that, overnight or whenever your application workload is not at its peak, you can help manage costs in your environment. So let's take a look at doing that. So like I said, I'm just going to remove some lines from my HCP Vault configuration so that the secondary cluster is no longer defined, remove my output, and change my tier down from the plus tier to the starter tier. So when I apply the Terraform configuration, the first thing you're going to see happen is the secondary cluster is going to be deleted. Since that's attached to the HVN, I can't delete the HVN first, so that's going to get deleted. Again, all this while HCP Vault is running, so anything that needs to access your primary cluster still has access. So that's been deleted. Then my HVN can get deleted, and my cluster can be scaled back down to the starter tier. So notice here that it's back in the updating state, and my tier has changed from plus to starter. And that will come down and complete. So you've now scaled up your cluster, you've added replication, and then sometime post adding replication, you've got to a point where you didn't need that replica anymore. You can pretty easily remove it and scale your cluster back down to a small tier. So to wrap up, you've got codified Vault configuration. You can use this to help teams that maybe need to consume Vault or test Vault locally. Maybe there's a development team that needs to run this locally and test some integrations. By codifying that configuration, you can pretty simply migrate that to HCP. Once you're in HCP, as you just saw, you can manage the lifecycle from scaling your HCP Vault clusters up and down, all through Terraform. You can add performance replication, you can manage path filters, and this is all done directly through Terraform. There's no need to access Vault in order to manage path filters. And you can also manage costs. So once your environment's at a point where all those resources aren't needed, you can apply the appropriate tier to match the resource demand. Some additional resources here that I think are also available in chat. So here are the GitHub repos that both Brian and I's labs were based on. So if you want to follow along, you can visit learn.hashicorp.com, apply your codified OSS Vault config, and then migrate that to HCP. And then you can switch over to the Manage HCP Vault with Terraform, learn tutorial, and get some hands-on changing the configuration in Terraform to manage your HCP Vault environment. If you don't have an HCP Vault or HCP account today, you can sign up for one at cloud.hashicorp.com. And this was all done with Terraform. So if you're new to Terraform, check out terraform.io and check out some of the docs and guides that are there as well. And with that, do we have any questions? My chat looks pretty quiet. So with that, we are wrapped up, and I've been asked to have everyone head back over to track 1. Thank you very much for coming.